Review of final assessment solving. Question number 1 has the instructions that read solve using quadratic formula. So we have the problem 8x to the second power plus 7x equals -2. The first thing we need to do is move that -2 over to the left side of the page so that we have our trinomial equal to 0. So I'm going to sum a 2 to both sides, so I end up with an 8x squared plus 7x plus 2 equals 0. So now I have the trinomial in the form ax to the second power plus bx plus c. My a position has an 8 in it, my b position has a 7, and my c position has a 2. I'm going to use the quadratic formula, which is x equals -b plus or minus the square root of b to the second power minus 4 times a times c divided by 2 times a. So coming down here, I'm going to plug those values in. So b is equal to a 7, so I have a -7 plus or minus the square root of 7 squared minus 4 times 8 times 2 overall divided by 2 times 8. Now I can begin to simplify this problem. I'm going to take care of the math that's underneath the radical sign. So I have a 7 times 7 to make a 49 minus a 4 times an 8 times a 2 to create a 64. While I'm doing this, I can then put in my division bar and take the 2 times the 8 to get the 16 as well. Now I'm going to take the 49 minus the 64, and this is going to result in a -15. So now we're going to have to deal with imaginary numbers. The square root of a -1 is I. So I'm going to pull an I outside and leave a +15 on the inside. So I end up with a -7 plus or minus I times the square root of 15 over 16. There's nothing more I can do with this problem because of the imaginary number, so I'm going to stop here. This is my final answer. I'm going to move on now to the next problem where it says solve. I have the square root of 2x plus 3 minus the square root of x plus 1 equals a 1. So what I want to do with this problem is get rid of the square roots. Before I do this, I'm going to take this minus square root of x plus 1 and move it to the other side so that I have a square root on both sides of the equal sign. So I'm going to move this problem over. It creates a 1 plus the square root of x plus 1. Now I'm going to square both sides of the equation to clear these square roots. So I end up with an x plus 3 over here. On the other side, by squaring these two, I end up with a 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. I'm going to use the FOIL method to pull these together. So I have 1 times 1 creates a 1 squared, and I have a 1 times an x plus 1, so I get a plus x plus 1. Then I'm going to look at the inner, so I have an x plus 1 times a 1 to get another x plus 1, and finally I have an x plus 1 times an x plus 1, so I have it 2 times, so I'm just going to put it in parentheses squared. So I'm going to continue to simplify this problem out. So 1 times 1 creates a 1. I have an x plus 1 2 times, so I've got a 2 times an x plus 1. And then a plus x plus 1. Where this came from was I have the square root of x plus 1 overall raised to the second power. That clears my square root, so I'm left with x plus 1. Continuing on to simplify, let's continue to add or combine like terms. So I have a 1 and a 1 over here, so I end up with a 2. And I'm going to pull this x in the front so that I can just have it flowing simply. So I have a 2 plus an x plus a 2 times the square root of x plus 1. Next, I'm going to bring this 2 and this x to the other side to combine them with the x and the constant on the other side. So I'm going to subtract the 2. I'm also going to subtract the x. I'm just going to do this in one line rather than doing it in 2 steps. So I have a minus x here and a minus 2 here, so that I'm left on the left side with a 1x and then a 3 minus a 2 to create a 1 equals, these two canceled each other out, they went down to 0, and I'm left with 2 square root of x plus 2. I'm going to go back to the step I had before again, and I'm going to put parentheses around these and I'm going to square them. So I'm going to end up with an x plus a 1 2 times, so x plus 1 times x plus 1. On the other side I'm going to take this 2 and I'm going to bring it in, so it's going to be a 2 squared. And then when I bring in the 2 onto the square root, it comes down to an x plus a 1. So let's simplify it. We'll use FOIL over here on the left side, distribute the x to the x to make an x squared, an x times a 1 to make an x, 1 times x to make another x, and then 1 times 1 to make a 1. Before I look at the other side, let's combine these like terms. So I have the x squared carried down, an x and an x makes a 2x, and then plus 1. On the other side, that x squared made a 4, and I'm going to distribute that 4 through the parentheses, so 4x, 4x, 4 times 1 to make a 4. So again, what I'm going to do is pull everything together on one side and let the right side be zeroed out. So I'm going to subtract the 4x off so that I can subtract the 4x off the 2x on the other side. I'm going to subtract the 4 off the right and off the left. So I'm left with x squared minus 2x minus 3 equals 0. Now I have a trinomial, and I can factor this problem. So I look at my C position, it's a negative 3. I look at my B position, it's a negative 2. So I'm looking for a pair of factors that will get me a negative 3, and when summed, make a negative 2. So a 1 times a 3 is going to make a 3. I know that I need that those two, if I subtract them, will make a 2, but the 2 has to be negative, and the 3 has to be negative. So I'm going to put the negative sign on the larger one so that it makes the negative 3 here, but also when I bring it to the other side and sum them, it leaves me with the negative 2. 1 plus negative 3 equals negative 2. Now I can take those numbers, set up my binomial, so I'll set up my parentheses, my x squared, one of the x's goes in the first binomial, the other x goes in the second one. Then the factors I just found, I'm going to put 1 in, so I'm going to take that plus 1, and then in the other one I'm going to put that minus 3. So I have x plus 1 times x minus 3. And set each of those equal to 0 now to solve out. So x plus 1 equal to 0. When I come down here, I'm going to subtract out. So I've got a small error here. I've got a minus 1. So that should make this a negative 1. I've got an add 3, so I've got a plus 3 over here. So this is a negative 1 comma positive 3. Question number 3 has the square root of 3x plus 10 equals a 5 minus a 2x. So to clear the square root over here, I'm going to take and I'm going to go ahead and square each of these or raise them to the second power. So I'm going to put my parentheses in. This will clear my square root on my left side, so I'm left with 3x plus 10. On the other side, I end up with a 5 minus 2x times a 5 minus 2x. I'm going to use the FOIL method to combine these. So 5 times 5 for 25, 5 times negative 2x to make a negative 10x, a negative 2x times a 5 to make a negative 10x, and a negative 2x times a negative 2x to make a positive 4x squared. Combine the like terms, so I end up with a minus 20x to the center. Now I'm going to pull this 3x and this 10 to the other side. I'm going to subtract the 3x and I'm going to subtract the 10 off both sides of the equal sign. So I'm left with 15 minus 23x plus 4x squared. So if I turn that around so I see it as a trinomial or quadratic equation, pull the 4x squared to the front, minus 23x plus 15. Now I can begin to factor this problem. I have in my A position a 4, in my B position a negative 23, and in my C position I have a 15. So I'm going to use the A times C method to solve this problem. So A times C, 4 times 15 to get 60. Now again I need a pair of factors that when multiplied together make a positive 60 but create a negative 23. So to create a positive here in the front position but a negative on the second, I'm going to need to put negatives on both of the values or both of the factors. So I have a negative 3 times a negative 20 is equal to a positive 60. A negative 3 plus a negative 20 makes a negative 23, which is the B. So now I'm going to take those two terms and I'm going to use them to replace the middle term. So if I come back up here, the original middle term was a negative 23x. I'm using the two factors I found to replace that number. So I still have the same problem. I still have, if I sum the two middle pieces together, I still have the same problem. But now I've got four terms and I can factor by grouping. So I have 4x squared minus 3x minus 20x plus 15. Now I can put in parentheses or brackets to group them. On this first pair, what they have in common is an x, so I'm going to divide an x out. So the x comes to the outside because I divide it out. A 4x squared divided by an x leaves me with a 4x. Copy down the minus sign. A 3x divided by an x leaves me with a 3. On the other side, I see that what they have in common is a 5. Also, there's a negative in this first position, so I'm going to take the negative out with it. So I have a negative 5. What's left inside after the 5 divides through is a 4x, and then a 5 into the 15 leaves me, a negative 5 into the 15 leaves me with a negative 3. So now what I have in common are the two binomials, the 4x minus 3, 4x minus 3. So I'm going to divide those out next. So I divide them out and I put that 4x minus 3 to the outside. Once those are gone, if I cross them out, what I'm left with is x plus negative 3, or x plus negative 5, or x minus 5. So that's my next one. I'm going to equal each of these to 0 now, and I'm going to solve to see what x could be equal to. So I'm going to take that 4x minus 3 equals 0. I'm going to add the 3 to both sides. That leaves me with 4x equals 3. Next I'm going to divide that 4 out on both sides. So I'm left with x is equal to 3/4. On the other side, I'm going to add the 5 to both sides, so I find that x is equal to a 5. I can actually check these answers to see if they're correct. What I'm going to do is come back to the original problem and plug the values in and check the answers to see which one works, or if they both work. So I take the 3/4 and I plug it in for the x here, and I plug it in for the x on the other side here. I'm going to solve this thing down. So I end up with a 9/4 plus a 40/4. Add those together, I end up with 49/4 square root equals a 10/2 minus 3/2. Now if I take the square root of the 49, that's a 7, and the square root of the 4 on its own, it's a 2. A 10 minus a 3 leaves me with a 7 over 2. So this creates a true statement. So this answer is a correct answer. It does work, so I have 3/4. I want to do the same thing with that x equals 5. I plug it in. So I end up with a 3 times a 5 for 15 plus 10. So 15 plus 10 for 25, which creates a 5. On the other side, the 5 minus the 2 times 5, so I have 5 minus 10 makes a negative 10, so I end up with a negative 5. This one doesn't work. So my only possible answer will be the 3/4.